Well, welcome everybody to our webinar today, introducing the US Census and ACS data analysis into undergraduate courses. I'm Bill Frey. I'm with the Social Science Data Analysis Network here at the University of Michigan. And I'm joined by Jill Bouma of Berea College, Kathy Rowell of Sinclair Community College, Esther Wilder of Lehman College at the City University of New York, and J.P. DeWitt, also of the University of Michigan. This is a webinar which will allow you to understand how to integrate US Census data and American Community Survey data into your undergraduate classes. We've been doing this for a long time, but this is our first internet webinar for the SSDAN project. The people who are going to be presenting today know a lot about how to use census data and show census data examples in their own classes and have done a lot of webinars with us in the past. So this will be an important opportunity for everyone to share in. We're also going to have some breakout groups along the way. I say a little bit about our project, the SSDAN, the Social Science Data Analysis Network. It's located at the Population Studies Center of the University of Michigan inside the Institute of Social Research. We've been making demographic data accessible to the general public and to use in early level undergraduate courses since 1995. We've been doing webinars, we've been doing workshops, we have a website that allows people to put together and download and use in their classes easy to use course modules and data sets. That's what we're going to show you how to use today. We have classroom learning modules, data sets, guides to graduate programs in the population sciences. Our webinar and our project is supported by NICHD. So I'm now going to pass the baton over to Kathy Rowell, who's going to tell us a little bit about the workshop goals for today. Kathy.
Thank you. So there are a lot of workshop goals if you read the description of the workshop, but these are some of the major things that we're going to be covering today, and also probably learning other things. And I'm not going to read this slide for you. I just want to encourage you to look over it. This was what we advertised that we'll be doing, and it is an interactive workshop, so we look forward to your participation. So just to note that we are recording this session, but we'll be editing to remove any captured participant information. We do ask today that you place any questions you have during a presentation in the chat area. We will be monitoring that, and then there will also be time for questions and answers throughout the workshop. And then finally, please keep your audio muted unless you're participating. And finally, this is the agenda that we're hoping to do today. You never quite know how these things are going to go with webinars, but we do have some built-in breaks, and we hope that you note those in case you have things that you need to do. And we do also have time for Q&A after each 1 hour as well. So we look forward to working with you during this webinar.
So thank you everyone for coming. And if you're here, you probably have your reasons. But one of the things we just wanted to focus briefly on is why do we see the ACS, the American Community Survey, and related census data as useful for a wide range of courses? And that's really because the content is interdisciplinary. It covers a wide range of topics. The American Community Survey covers a wide range of topics that are really applicable to some of the disciplines that you see listed there. Further, we see the integration of data analysis as really supporting a wide range of disciplines, not only those who major in the social sciences. Social sciences attract students from a wide range of disciplines, including the hard sciences. I always like linking to this paper. It's mentioned here. It was published in 2001 in Nature Neuroscience, and it looked at the use of statistics in neuroscience research. There was a review of 513 neuroscience articles in the 5 top neuroscience journals, including Science and Nature. And it was actually found that the t-test was misused more frequently than it was used, which, for those of you who know about a t-test, it's one of the simplest statistical tests out there. And to understand that NIH is funding typically over $5 billion of research each year. And a lot of the research that's being produced from neuroscience ends up not using those and ends up not interpreting their data correctly. It's just kind of an alarming thing. And so we see this as an opportunity to get students working with quantitative data, not only in the social sciences, but throughout. As we've seen more and more over the last decade, and especially over the last few years, information is crucial. The ability to critique and understand data that are out there is more and more important for an engaged citizenry. And more occupations are requiring some sort of data-driven decision-making. So we see getting students' feet wet working with data, getting them comfortable working with data is very important going forward. And I'll hand things off to Bill to talk a little bit about his development of SSDAN and data counts and how he sees data analysis really leading to a more engaged and educated workforce and citizenry.
Yeah, well, thank you, JP. You know, the main idea about what we're doing today and what a large part of our project has been since it started is to try to integrate data analysis into courses that typically didn't have data. We're talking a broad range of courses, whether it's introductory sociology, introductory or immediate courses in all of the other social sciences, substantive courses, whether it be on gender studies or race studies or the workforce and any of that. Often in the past, lots of these courses didn't have hands-on interactive data analysis opportunities for students. They had to wait until they took a statistics course or a methodology course to actually use data. And our idea is to try to make it easy for teachers and for students to work with data, and especially census data and American Community Survey data in any kind of course. And part of the way we do this is to make our data analysis simple. Typically, we use two-way tables and charts based on those two-way tables to be able to introduce, you know, the idea of having a hypotheses or generalizations about things that you want to have students better understand. So you can see on this particular example, you can have a module that starts with a question: how does the year of immigration, year that which the foreign-born have come to the United States, affect their English-speaking ability, and does race matter? So those are two kind of simple questions you might have in some kind of sociology course that deals with immigration. And so, you know, we have very simple data sets with only 3 or 4 or 5 variables in them, but enough to be able to have students try to figure out the logic of how you would put a two-way table together to be able to answer that question. Of course, you as a teacher have to figure out which data set to give them so that they could answer that question. So here's a simple table where you would have as one variable the English speaking ability, and then here you see in the column variable, or the row variable and the column variable is when did they immigrate. So the idea, the hypothesis is the longer you've been in the US, the more likely that you can speak English very well if you're coming from a country where English would not be the native speaking language. And of course, then the student understands which way to percentage the table and maybe make charts and graphs from that table. And this kind of example, it could go in any level of course. You know, if you can put it in a way where the substantive topic interrelates with what you're trying to teach anyway. And so that's basically our idea here. And you'll see many examples of this today, and also from our instructors, how they've been able to do this, their experience in using this in their classes, and also in the last part of our webinar, how you can assess whether or not your students are learning this stuff. So we're going to begin right now with Jill Bouma of Berea College, who's going to go right into it, dig right into one of these examples. So we're going to send the baton over to Jill.
Okay, thank you. Again, I'm Jill Bouma, and I am going to screen share and just take you straight into a PowerPoint. Let's see. Okay, so I do this in a social problems class. I'm looking at the influence of race and sex on income. It's a 100 level course I've done this with. It's non-sociology majors as well as some who are trying out the class for the first time. I typically have 20 students in the class and all of them have a laptop. I usually take 4 to 5 days to do this, but you could certainly make it shorter or longer. The substantive goals I'm hoping students will learn. I want them to learn about sex and race differences in income. I usually introduce this about the middle of the course. So we've talked about inequality, we've read about it, we've read narratives and accounts. Now I want them to actually find evidence in data, and I want them to find it themselves so it really feels real. They're going to make national and state comparisons in terms of earnings using the ACS PUMS data from 2012 to 16. The quantitative skills that I hope they're going to learn, I don't know why this is doing this. They're going to create and read frequency tables. They're going to learn the logic of independent and dependent variables, create and interpret bivariate tables or crosstabs, learn to make data-based comparisons across states. And if it all works, my great hope is that they learn to read and write a story about income inequality using data. Again, I'm teaching them how to write, but they're going to learn how to use data as evidence as they construct a story. So on the first day, I would give them a handout, and this handout will be included for you if you're interested in using this later. And the first thing I do is I help them understand, well, what's a sample and what are variables? We'll spend a little time talking about that. And then we're going to jump right into frequencies. And so we're going to look at, the sample here is all full-time year-round workers in 2016. We'll talk a little bit, what does that mean? Who is included in this? Who's not included? And then I'll look at a very simple frequency. Anytime I show frequencies or really any kind of data, I always ask students to guess first, rather than just flashing a table at them. I always want them to try to think about it. So they actually kind of think about, oh, what's coming? So I would just ask you, like I would students, well, what do you think the sex composition of the full-time workforce is? Do you think it's 50-50, 60-40? I let students guess. It's always kind of interesting to hear what they say. And then I show it. So here it is. About 57% of the workforce is male, about 43% female. Again, this is quite simple, and yet there's actually a lot to sort of share with students when they start seeing these. So the first thing I point out, well, we have both percentages and numbers. And I'll ask them, well, what makes the most sense to use? And I always have students who want to use the numbers, and especially in papers, and I don't know if it makes papers longer, but as you can imagine, it's not terribly effective. And so we'll talk about why. Why would we want to use percentages to make comparisons? And then I'll say, well, because we don't have the same number of men and women, and we'll talk a little about that. I also point out that percentages should add up to 100%. And again, I know this seems very simple. This is for a 100 level class, but that these are common problems that come up. And that they have to understand the base, that this is all full-time year-round workers. Okay, so what I immediately, after showing a frequency, I look for common mistakes because they'll read them wrong a lot. It's very easy to do. So I'm just going to do this with us for a moment. Which of the following is true? Is it true that 57% of the workforce is male, or 57% of men are in the workforce? And we'll do this together. So just take a quick anonymous poll. So I think Kathy or whoever's doing that, if you could just launch as a quick little poll. So looking at that. So if you all would just take that very quickly. Okay. So it looks like most people chose A, and in fact, I'm going to move that now. In fact, that was correct. So the answer is A, 57% of the workforce is male. Most of you got it. But again, these are really easy to misread. And I will very frequently have students say, oh, only 43% of women are working. So it's really important with frequencies, even something this basic, to really help them understand what we're looking at. Okay, so I'll move on to the next one. Why am I frozen? Looking at earnings. So again, I ask students to guess, and I will ask you, what percentage of full-time workers do you think earn over 100,000? This is really interesting and will vary by your students. I'll ask my students, do you think it's 50%, 10%, 1%? And they'll kind of jump around the room and guess. And then I ask, well, what percentage of full-time year-round workers do you think earn less than 25,000? Again, half of them, a quarter of them, 10%, 90%. I work at a school of almost all working class, low-income students, so they tend to think the majority fall under 25% or a large portion and very small, making over 100,000. We guess, and then I show them the frequencies. And here, what you can see, I always have a couple students who've actually guessed it exactly right. In fact, about 12% of the full-time year-round workforce in 2012 to 16 earned above 100,000, and about a quarter, 23%, earned less than 25,000. It's interesting to talk about that, what that means. These are people, again, working full-time year-round. So we look at that for a little while, and then I want to go from here to looking at variables together. Now we'll start creating crosstabs and bivariate tables. So I asked students to guess, well, who do you think makes more, men or women? And someday I hope that the answer is not quite as obvious as it is today. Almost all of them guess men. And then I say, well, how do we determine that? Given the two sets of frequencies we've looked at, we typically think of comparing mean, average incomes. Now we're going to look at it in a bivariate or a crosstab. So I will show them a bivariate table, and here it is. Most of them have guessed that men earn more. So now we look at this table and I ask them, well, is it true? Do men earn more? And one of the first things I've learned is that they don't really know how to interpret this. It's a relatively simple table, but there's a lot in it and they don't know where to focus. Sometimes I'll have them focus in the middle. So first thing I do, especially since we have an ordinal variable earnings, is I will tell them, well, let's focus at either the top income categories and compare percentages of men in the high income versus percentage of women in the high income, or at the low income, but let's not focus so much in the middle. So I teach students to focus as much as possible on the high income categories or the low income. So then they know actually where to focus. Right, then next, I realized after teaching this very quickly, they don't really know what those cells mean. What does 21.1% mean? And so I start putting together very quickly these little true false things. So we'll do that here. We can do it in a poll. There's 4 questions here. And if you would just take that quick poll and answer true or false for each one of these, and then we'll have a quick sort of see where students are at, what we're asking students to do. So Kathy, if you could launch that. Okay, did you just run the results? Is that correct, Bob? So you can see here, this gives you a taste of what I ask students to do, and I will quickly then go over the answers. I can see again, most people got these right. So let me just show you. Why is this not working? So do 21% of those who make less than 25,000, are they actually men? No, that's false. It's 21% of men who are earning less than 25,000. And this is a really easy mistake to make. This is the most classic, and I do this sometimes. It's very easy to look at. It's really important here to help students understand that we have to figure out the base. So this is all men, right? It's percentaging down within this column and percentaging down the column of women. So this is the base of all women. Here we have all men. It is not, this row is not all earners earning less than 25,000. So the first one is false. The second one right here, 13.8% of men make between 25,000 and 34,000. That's true. The next one asks you about adding within tables. Can I add down this can I add this at 17.8% of women earning 70,000 or more? I can add down because this is within the same base of women. I can do that, but I cannot add across. I can't add 100% this out of the making over 100,000. So that one's false. So we do this, and I will, with my students, I'll grab a statistic like 16.6%. I'll ask a student, make a sentence with that. I'll have students make up true falses. I'll have them quiz each other. It's kind of fun and it's easy to screw up. I do it too. They'll catch me and it's fine. I've seen many faculty in our department, on our faculty floor read these wrong. If we can help students actually read a basic bivariate, we're really helping them. A lot of people make mistakes on this.
Jill, we have a question in the chat box about that table.
Sure.
I was going to see if you would take a minute to answer it.
Sure. Can you read me the question?
What is the analytical implication of presenting such table using row distribution instead of column-wise?
Okay, it does not matter. You could do either one. I have just set this up. I teach statistics and methods in our upper level courses, and I just use Earl Babby in sociology, and he typically sets them up this way. It does not matter which way you do it, and I will switch them. I'll try to get students to learn later that really you just figure out which ones are the base. So figure out where these are going down the columns, right? Down the rows into 100%. So it does not matter. You just help them understand which way you do it. Bill, I think, is going to show you switching them. So I just try to get them used to it this way, and then later I'll start switching around. Does that seem to answer it? Do you think, Kathy? Okay. All right. So once they've learned how to understand what those specific percentages in each cell mean and how to use them, then we move out to the table. Well, how do I describe a table overall? And I realized after teaching this many times that I'd kind of developed my own rules, and you will too. And so you can make up your own rules, but here are sort of the Bouma rules I've come up with over the years. And I have done it. I teach writing as well. And it's kind of a standard: start with your thesis statement, then develop the evidence and summarize. And so for what I think of describing tables like this, I tell students, we'll start with a general statement. And that general statement is your take-home message from this table. It's not a bunch of numbers. So for me, the simplest here, start with a general statement: men earn more than women. I don't put any numbers in it. Make it very simple. Then the second thing is they have to start building their evidence. Well, if someone didn't believe you, what would you tell them from this table, that story? So we work on that a little bit, but here's something we for. We see that 29.2% of men, adding these two categories, earn more than $70,000 compared to only 17.8% of women. Furthermore, we could talk about, 44% of women earn less than $34,000 compared to only 35% of men. You can take it as far as you'd like. And then I just tell them, end with a brief summary. Overall, then, more women than men fall into the high income categories, while a majority, I can't read the bottom of my screen. So you can see, just end with a basic summary. And what I'm really trying to get students to do is tell a story with numbers, build their case. And I always say to them, I will have a student read aloud, and then I'll turn to another student and say, okay, what was their main point? And if they can remember it and give a little bit of evidence, then I think they're successful. So it's a lot of practice. Okay, so looking at race, the PUMS data define race with the following categories: non-Hispanic white, Black, Asian, Hispanic, Native American, non-Hispanic other, and non-Hispanic multi. You could spend a day just talking about how these are socially constructed, and we talk a little bit about that. So given these categories, I'm going to go back now to a frequency. Guess the racial composition of the US full-time year-round workforce. These are always astonishing to me, how students first guess. When I've taught racial composition of the US, it reflects where they come from. So here it is. What we see is about 65% of the full-time year-round workforce is white, and you can see down about 11% African-American. This very closely reflects the overall population in these years, and the students who remember that from earlier guess quite close. Okay, so now I'll ask them, well, which racial or ethnic group do you think earns the most and which earns the least? And we'll bounce around the classroom as people guess. I always want them to guess, trying to figure that out. And then I show the data. And you put this up there and they kind of cross their eyes and it looks pretty overwhelming. And we look at it and we talk about it for a while. And then this is where my first class ends. Everything we've just done, plus more, describing dependent and independent variables, is in a first handout, which you're welcome to. And I end the class with this table and I say to them, okay, your homework is to describe this table, write a story about this table in the ways we've just learned, and come in tomorrow and turn that in, or we'll read it in. So the next day they come in and they read aloud, we work on it, we sort of laugh, we make it beautiful or it's not so beautiful. And this is the kind of practice we'll do over and over. And we'll remember back the first time they saw it and it looked terrifying. And within 3 days, they can just zap these out. So that's where I would end the first day. We come back, they read aloud. And then on the second day, I get them into the data themselves. They are now going to get into the data. And I would like to take you all into the data. So Kathy, if you could put into the chat, it will bring in this website and it will sort of lead you into what I'm about to do. And I am going to go ahead and click on this website and it should bring you in there. And Kathy, is the chat, if you can just give me a finger, is it in the chat now? Okay.
Yeah, it's in the chat.
Okay, thank you. All right, so, and you can just follow along right now because we're going to give you some time in a breakout room. So under collections, we're going to scroll down and there are some GEO ones, and GEO 2016, we're going to click on. And oops. And that's going to open up a set of data sets, and it's going to have all the states, which is really kind of fun. And I'm going to show you my state, which is Kentucky. Okay, when you do that, and you can choose your own states, or you can just follow me right now. This will have, you'll see the description. It shows earnings data for Kentucky, 2012 to 16. And then we have 4 variables: earnings, race, sex, and age. And it just shows these. And then I will tell students, let's look at the frequencies. Let's see what the sex composition and the age composition and the earnings. So to do that, I wish it said frequencies. It says compute marginals. So if we hit that and then scroll down, it's going to show the frequencies. And here they are. And if you remember from just a moment ago, when we looked at the overall racial composition, it was 69% of the workforce was white. Now notice in Kentucky, it's 87%. We have very little diversity. This is a white state. So it's one of the first things students are like, wow, really different. And they're going to get into their own states and really start making sort of discoveries and comparisons. We see that the sex composition, very similar. In fact, it's similar pretty much across all the states. I don't really look at age, but you certainly could. Some interesting things there. And here we look at earnings. Now we see that Kentucky is a poorer state. Only 7% of the Kentucky workforce made above 100,000 and a little over a quarter. So we'll see that compared to the United States as a whole, Kentucky is a poorer state. So I will have students, when they get into their own, it's kind of interesting to go state by state and look. And now what I want to do is just show you briefly one way to set up crosstabs, and you can play with them and set them up in different ways. But just for standardization's sake right now, in the row, I'm going to put the dependent variable, which is earnings. That's earn 3. So in the row, I put the dependent, and in the column, I'm going to put the independent, which let's just look at sex right now. I'm going to not look at controls yet. I'm going to generate a table. And because of the way I set it up, with the dependent in the row and the independent in column, we need to percentage down. If you look through them, it'll make sense. I'm not going to explain that now. And you can play around and see what happens if you don't. Students always make mistakes, and it's kind of fun to figure out. They figure out why. So here you see now a crosstab that shows gender differences in income in the state of Kentucky. And this always kind of ticks me off, frankly. We see 22% of men earn above 70,000 and barely 10% of women do, a little over. So this is interesting to get started. So once we've done this, what I now do is I take students and I let them go into their own data set. I let them get into this and go into their own state. So I think what we might do now is go into breakout rooms and let you all just play. You can pick what you might want to do in a group is decide on one state to look at together, or you can do your own. You can decide what you'd like to do. And we'll give you probably about 12 minutes or so. Does that sound right, Kathy? So,
Yeah.
Okay, so we'll put you into breakout rooms for about 12 minutes and you just play, get into the data and play around. And we'll let you go, and we'll come in and visit various ones. Okay, as people come back, I think we'll start. If you have questions, you can put them in the chat, or we will see as we go. I'm going to try to go back to share screen and just quickly sum up. So can I do that? Okay, here we go. So let me go back to my PowerPoint. I've been seeing myself. What I really want is my PowerPoint. Can you all see my PowerPoint now?
Not yet, Jill.
Okay. I'm not sure. Can you see it now, JP?
Not yet.
Am I doing something wrong, or does someone just need to give me control?
You might have to hit the share screen again.
Okay. Okay.
There we go.
Okay, great. All right, I just want to give a brief overview of what I do when I teach this. So I introduce and demonstrate US data on the first day, very much like we did. It's much more interactive. Students are asking and guessing. The second day, just what you just did, but we spend a whole day with it, where students play with the data, they explore the different states. I have them, as they're learning about it, to talk about, well, what is the racial composition in your states? And they look for what is the most diverse state, what's the least diverse state. It's really quite interesting. And then on the third day, I have them come in and present what they learned about their state. So I run it on my computer. I put the tables up, or graph, but usually the table. And I usually do the one on race and income because it's more complex. And then students in pairs come up and explain what they see. And the first times it's kind of clunky, and that's great. It gives them a chance to practice it, to keep talking about it, to try to convince others. And it becomes a consistent story, which can be kind of depressing. And then we talk about that later when we get to our conclusion. The fourth day, I do a peer review. I have a full-blown paper for this, where they're including lots of tables. They're writing up an intro, a lit review, the data, the results, and then the conclusions. And then I have the paper due on the fifth day. So it takes me 4 days, and the paper due on the fifth, or a few days later. I give them extra time, but we move on to other things. And everything, all my materials are available online. You're free to use any pieces you'd like at this website, and JP will be sharing more later. I've assessed this in 2 different ways over time. I use a pre and a post test, and also this paper, which I grade with the rubric. And I try to assess both skills and competence levels. One of the things that just breaks my heart is how much students don't like math and don't like data. And I'm on a sort of personal, all of us in this group are really trying to enhance students' really love of numbers and interest in this. So when I look at the pre and post test, this is my last batch of grades or scores. I give the pre-test on the very first day of class. Obviously, it's not graded. They make a 65%. It's 22 points. The range is 11 to 88. By the post test, which I put on their final, it's 90%. So they definitely learn. It's really gratifying. And you can see the range improves quite a bit. So what I find from this pre and post test is great improvement in basic skills. I choose a different state, and for the final, that one that no one's done, I put a table on and I ask similar questions to what they did for their paper. And they definitely learned it. And they also are more confident in working with data. I've had students tell me it's the first time they have ever liked working with numbers, that they've ever liked math. And it just thrills my heart. So the paper itself, it's a hard paper. It's 8 to 12 pages long, a lot of tables, and I'm very fussy at what tables have to look like. The skills vary quite a bit. The peer review really helps, mostly because they can catch errors. And I speed read a paragraph or 2 from each paper as well. I do allow rewrites for students with the most trouble, though they've gotten so much better, and maybe I've just gotten better at teaching it. I haven't needed that so much in recent years. They report that it's difficult, but worth it. And these are just on student evals. I didn't even prompt this, but these anonymous evaluations at the end of the semester. Here are a couple ones I've taken over the years. I worked a lot in this class and was always taken to the brink of overwhelmed, but not crossing over. I think this is a sign of an excellent class. The data analysis we did was a particular challenge. I came away from the exercise knowing I learned something completely out of my comfort zone.
Bill, I'm sorry to interrupt, but you have a question that I wanted to make sure we answered. What is the prompt you use for the paper?
I have them they have to examine the effects of race and sex on income in a state of their choosing and compare it to either the US or Kentucky. So they're looking at one state of their choosing, both race and sex differences, and they're comparing that to another state or to the US. So it's a pretty big, complex paper. Thank you. And that assignment is included here. So thank you, Kathy. Here was another student's comment. Keep on trying with data analysis. We, the students, need it, no matter how badly we do not like it at first. They do come around. And then at the end of every class, for all my classes, I give just anonymous feedback. I give a sheet and I ask their opinion basically on every assignment and book and say, what did you learn? What did you like or not? And should I keep it for the future for other students? And here are what I got from the last time I did it. Data analysis was very helpful. Glad you made us do it. data analysis. I love this paper. I learned so much, and it made me switch from chem to soc as a major. Boy, I felt such triumph. Data analysis paper allowed me to effectively read and report data. I got no negative comments the last time I taught it. And believe me, I get negative comments. So this was a real, it's fun to do. So the module, this one that I've just walked you through, I've been using for several years. It's the most recent data are 2016. Cheerleading really helps. I just keep telling students, remember the first time you saw one of these and couldn't do it, and now you can just zip out these explanations. It's fun to teach. It's hands-on. Students generally enjoy it. The pre and the post tests definitely show they learn these skills. And the exams and the papers show that it reinforces the content. They really get these earning differences. It's not just something they've read, they've seen the data. And I see evidence of these quantitative skills in later courses. Because again, this can be their very first semester in college when I introduce this. Main tips, more time is always better if you can give it. Ungraded feedback has been my best friend. I ask for a table with a paragraph. I give lots of feedback, but I don't grade it. That helps them clear up misunderstandings. It helps me to know what to emphasize more. I give lots of chances to practice. I have them write in class, read it aloud, rewrite it, present it. Expect they're going to make mistakes, and I make lots of them, sometimes on purpose, but often inadvertently, and that's great. Then we all learn together. And if you do require paper, it's great to try to break up the pieces. I'll often have the lit review the first day. I'll have data sections so that it doesn't all have to come at once. And finally, what this module includes, 2 handouts. The first one is the explanations of variables, descriptions for how to read frequencies and bivariates. That's what we sort of did. Handout 2 gives you step-by-step instructions for the students to go online and look at an individual state, and it has the whole assignment for their final paper. I also have a true-false test I use to catch mistakes. The list of rules I've developed, you will come up with your own. You'll learn what your own rules are. Peer review guidelines, a rubric for evaluating paper, and also a pre and post test. And again, these are all, you're welcome to use them. And if you try it out and have any questions, you're always welcome to contact me via email. So I think that's it for me. Thank you.
Before we move to our 10-minute break, are there any questions about this part of the workshop? And we can open this up for verbal questions.
Yeah, I was wondering if you think you could do it in 2 days, because I don't think I could give up 4 class days to this.
Sure. I think if you want, I'll take this off here. I think if you want to not have a long paper, you can just do the data and you could easily do it the 2, because the first day I introduce them, the second day they play with the data, and you could have them a day writing a paragraph. You don't have to have a full paper. So I think you could easily make it 2 days.
Great, thank you.
So if there aren't any more questions, we have that it's 2:53 and we promised a 10-minute break. So we will start back. I'm trying to do math very quickly. We'll start back at 3:05. So we'll see you at 3:05.
Thanks.
Okay, we're back. It's 3:05 and I'm going to go ahead and get started. Hopefully you can see my presentation. If maybe JP or Jill would just give me a thumbs up.
You're all set.
Thank you. So my part's really quick and brief today. And in fact, I won't share all the links. I'm hoping that I will post this with SSDAN and you would be able to look at these later. Just a quick reminder about the importance of teaching data analysis and demography. And I'm going to focus more on demography today, but also the importance of data analysis, but also recognizing best practices with setting up modules and activities for students. And one of the things that you'll find on the SSDAN website, that there had been a lot of modules already pre-created for you, and you can download and edit those based on your needs. And most of them follow best practices for teaching and learning. So there are some really good websites that you can go to on how to create a good activity or module. It kind of depends on the verbiage. This is a Science Education Research Center. And again, I'm not going to click on all these today. We don't have enough time. but hoping that you might go back and explore some best practices in creating an activity for your students. And again, want to give out a plug that one of the reasons why I like SSDAN so much is that there are a lot of already pre-created activities that you can edit for your own needs in your own classes. So one of the things about modules and using data in the classroom is that they're active. And you had an opportunity to experience a little bit of that with Jill's, and Jill's does follow best practices. One of the things that I've been working on is the importance of making the data important. It comes out of a book called Make It Stick, but the importance of creating emotional connections. So for example, by having students research their home state, they're a little more emotionally connected to the work. But when you do data analysis in the classroom, think about using data or topics that the students might have an emotional connection to, or they might be more engaged. Another thing, and you saw that with Jill's module, is the importance of scaffolding. You might want to start with frequency tables and then work your way up to more complicated data analysis and introduction class. Typically, we do ask when you look at the modules on SSDAN's website that they're written for faculty, and they also include student activities. So it's really helpful to have some helpful hints for other folks that are going to use it. And if you download any of the modules that have already been created on SSDAN, you'll find that there's also faculty advice or faculty hints, and you have an opportunity to hear Jill give some of those in her presentation. And then the final thought, and we tried to attempt to do this in groups today, but the importance of team-based or pair-based modules. We found that students tend to learn better, especially with data analysis, when they're working in pairs or groups, so that they have an opportunity to talk to one another about it. So why does this matter? And I know Esther is going to speak more to this than I, and she does a lot of amazing work in this area on quantitative literacy. But it's important that students learn quantitative reasoning for public debate and social change. I cited 2 books that I think are worth reading and talking about as you think about how you want to do this in the classroom. But the importance of making data public and helping students understand why numeracy matters. And you noted that a lot of Jill students noted at the end that they really enjoy doing it. So if we make data analysis fun, interesting, and related to their lives, we find that students enjoy math, and it turns out they enjoy doing data. And I added just another reminder that if you do any of these assignments in class, think about ways that you can do this in groups and teams. You can also do this in online classes. I have students actually do some of these modules in my online courses, and they enjoy it. My students actually do something with Census Scope in an online course, which is part of the SSDAN package, and they do some work in classes. So there's some really great ways to do team-based learning with this work. So that kind of highlight what the basic module would look like. And we asked that if you design one to consider sending it to us so that we can put it on the website. But you saw Jill's is best practice. She had learning objectives. She included teaching facilitation notes. And a real important part that we often leave out when we create modules or activities for others is the assessment piece. And Jill talked a little bit about how she assesses for both quantitative literacy, but also competence. And I know Esther's done a lot of work in this area as well. That part of this is just looking at how we increase confidence levels with students. And I think that's been one of the greatest outcomes in helping my students at a community college, is that they walk away with a little more confidence in looking at numbers and interpreting them. And just a note about things, and you also heard Jill do this in her presentation, the idea of time. So this is where I really appreciated the question that we had. Most of us can't take out 4 days in a class. Most of the modules that I use are 1 to 2 class periods. I also have students do a lot of pre-work. So one of the great things about SSDAN is it's easy, easy to access from home, and students can do some of this at home. So having them do pre-work or pre-discussion prior to coming to class is a great way to save a little class time when you do some of this work. And then I've added a note on assessment. And again, I'm not going to click on all these links, but they're there for you. And then finally, as much as I like SSDAN, I think when you're thinking pedagogically about activities for classes, I think it's really helpful to look at some other resources as well, at least from the pedagogical standpoint. And if you're doing anything not in the United States, there's some really good resources out there and lesson plans for looking at demographic information. And I'll end it there and turn it over to JP and Bill unless there are any questions. So JP, it's yours.
Thank you, Kathy. All right, I'm going to, while I pull up my screen, I just wanted to remind everyone that the slides that we're showing today, including all the links that Kathy just presented, we'll send out an email in the coming days that will link to a page with all of the resources that we've been providing, or all of the slides that we're sharing today. So on that agenda, for about the next 35 minutes, we're going to go through two different topics. One is a brief introduction to the American Community Survey, just to give a quick overview of the American Community Survey and the census, how they relate, and what's included in the American Community Survey. The second half of the next 35 minutes, we'll actually focus a little bit more on the resources that we have at SSDAN. So as we talk about the American Community Survey, many of you may already be a little bit familiar with what it is. But what I want to do in the next few minutes is talk in a little bit more detail about what you can find in the survey, and a few characteristics about how it's fielded, what geographic levels of data are available, etc. So the American Community Survey was officially launched in 2005, and it is really the descendant to the decennial census long form. Every 10 years, for the decades leading up to 2000, there was a long form and a short form. The long form went out to about 1 in every 6 households, while the short form, which is now what we use as the decennial census, or very similar to what we saw in 2020, went out to about 5 in 6 households. The American Community Survey samples about 3.5 million households each year, or about 290,000 each month. So it's a little bit smaller each year, but it's giving data each year rather than every 10 years. The short form had just a very few, a limited number of questions that really dealt mostly with age, sex, race, and some very basic characteristics about the household. While the long form is where we get a lot of the data that we typically associate with the census. So things like income, educational attainment, some characteristics about marriages and families, some characteristics about the household. Only a small portion, though, of the population received the long form each year. The goals of the census versus the ACS also differ a little bit. The decennial census has really been focused more on counting the population, and this, I'll talk a little bit more about this, but it's really much more for apportionment, aimed at apportionment and getting a count of the population that can be used for other government surveys. What used to be on the long form from the decennial census is now found on the American Community Survey. That said, there are a few caveats to that. If you're interested in some of the US territories, data for the US territories, so Guam and the US Virgin Islands and the Northern Marianas Islands actually use a long form for the decennial census. Puerto Rico is the only territory that fields the American Community Survey. So to get the type of data that we would normally see from the American Community Survey in the territories, they get a decennial long form. As I was alluding to earlier, the decennial census really focuses on counts of the population for purposes of apportionment and redistricting. In a couple of years, we'll see state legislatures and committees formed the new boundaries for all of the state and congressional districts. Everything from Congress down to school boards will be redistricted in the next few years based on the results of the decennial census. The American Community Survey, however, supplements the census to provide timely estimates on a wide range of topics. We mentioned some of those earlier in the first hour, but there are a wide range of housing and person level, household level, person level, and family level characteristics that are provided by the American Community Survey. One of the caveats the Census Bureau likes to say is that the goal of the ACS is not to count every person, but to provide a picture of the characteristics of that community. So, as I was just discussing, there's really a wide range of content that can be found in the American Community Survey. We have social data, economic data, and demographic data. This is not even an exhaustive list. Every few years, the Census Bureau adds a new question. Later, I'll show you a link that you can see why each question is asked, but there's normally a regulatory reason for every question. Some of the questions that have been added in the past few years that are on this slide include educational attainment, the field of degree for educational attainment. And in the housing slide, there are some new questions that deal with internet and computer access. So normally I would go through a lot more in the sample design and data collection of the American Community Survey. We have a limited time right now, so I just want to point out that in contrast to the decennial census, which is a period estimate, or which is a point estimate for April 1st, the American Community Survey is a period estimate averaged across an entire year or group of years. So the American Community Survey is released in 1 year and 5 year data products. You may have heard Jill talking about the data set that she uses being a I think it was a 2012 to 2016 data set. The reason why it covers a span is it is, I don't want to say aggregating, it's pooling 5 years worth of data. There are multiple reasons for that, including the precision of the estimates that are calculated from the data. So the 1 year data tend to have much wider margins of error than the 5 year data, particularly when we look at some smaller level geographies. And with that in mind, as we talk about geographies, there are two basic types. There are the kind of legal administrative areas that we would, that we might be familiar with, states, counties, etc. But the Census Bureau, through the Office of Management and Budget, has defined a number of other statistical areas. So sometimes you'll hear people talking about census tracts, census block groups, which are the smallest level of geography for which the aggregate or summary data are available, and Boumas, which are the smallest comprehensive level of geography for which the microdata are available. Microdata are the respondent level data. They allow the data users to create their own tables, to do some of the more advanced statistical calculations. I think in my breakout group, there was a question about regression analyses, and that is something that you can do with the microdata. The summary level data are probably much more attractive for some of the early level undergraduate students, if you're going to be working with data outside of something like WebChip. Those aggregate based typically on a geography. So as I mentioned, there are a wide range of geographic levels available. Everything builds up for the most part from blocks, which are not actually on this. The decennial census has blocks. The American Community Survey has everything from block groups up to the nation. And you can see this is just the basic hierarchy. The microdata that we use to create some of the data sets in WebChip, however, typically do not go down below the state level. So in the last hour, we worked with some of the state level data sets. The microdata for privacy reasons does not provide the kind of pinpoint spatial resolution in order, because we want to be able to protect the respondent's privacy. As you saw on the last slide, the geographies are oftentimes nested or hierarchical. So I just like showing, this is a map showing changes in the racial composition of the census tracts in Baltimore metropolitan area. And I just like being able to show that, as you can see, the smallest level geography that are outlined are census tracts, which average about 3,000 to 4,000 people per tract. The larger borders are county level, and then the entire image shows Baltimore metro area. It's just again a kind of breakdown of what are some of the legal areas and statistical areas. I mentioned earlier that there are summary data and microdata. One of the key issues with the aggregate data, the summary data, are that in the one-year data release, not all geographies have data available. Because of those privacy reasons, because of the actual data quality, because of the sample size, only about 26% of counties actually have data produced every year. If you're interested in getting county level data comprehensively for the nation, you actually have to get it from the 5-year data. There are many resources for learning more about the American Community Survey and analyzing it. Some of our favorites are right here. There's, of course, the Census Bureau's main page on the American Community Survey. As I mentioned, there's a link here that provides why each question on the American Community Survey is asked. There's a rationale for every question there. There are also some other resources outside of SSDAN that we find particularly valuable or appealing for different reasons. I've sort of listed those here. Census Reporter is one of my favorite sites. If you want to find out more about a specific question, or you want to see what the question looks like on the American Community Survey, you can do so from there. You can actually pull up individual tables and see some of the tables from the latest ACS release. You can get something like an ACS data profile for a specific geographic area. You can put in an address and actually see what census tract, which cities are there, et cetera. So it's really a useful tool for doing a lot of different things. And it's a site that I encourage you to spend a few minutes playing with at some point. The Minnesota Population Center also has IPUMS and NHJS. One focuses more on the microdata, and the other focuses on the summary level data. But both of those go back as far as they can to the 1790 census. And they've harmonized the data over time. Social Explorer is a great tool for mapping. And if you ever want to see how companies might use something like ACS data outside of just kind of the scholarly research side of things, or for policy, Esri, which is known for its mapping products, has created something called Tapestry, where you can look up zip code by zip code and pull up some of the market segment analysis traits for each zip code in the country. And so if you ever want to see how ACS data might be merged with some other data sources to provide kind of contextualized information, that's another great resource. But the last thing we have here is our own resource, data counts. in just a moment, I'm going to hand things off to Bill, who will talk about data counts. But in addition to that, we have this link that's at the bottom. If you were just to even go on ssdan.net, you can see that we have some, we have a link to resources based on a webinar series this past month on accessing and analyzing census data in R. If that is something that you might be interested in for more advanced undergraduate students, or perhaps master's level students, that too is available. With that, I'll hand things off to Bill.
Okay, thank you, JP. I'm gonna do what I can here with the share screen thing. This will stop other screen sharing. Somebody tell me what to do with this. Will stop.
Here, I can, Bill, I can stop screen sharing. I'll quickly then talk about this for just a moment then, while you're pulling that up. So Bill is about to pull up data counts. There are something like 3,000 simple data sets that are repackaged. They remove a lot of the complexity of dealing with the microdata and really put in highly filtered, recoded data sets that are easy to use even for high schoolers or early undergraduate students who don't really have a background in stats or math or quantitative data. The whole idea is to make is to get rid of the complexity of a stats program and make playing with the data sort of fun and easy, easy to play with, hard to break. And there are data sets and modules that Bill will cover in just a moment that really cover a wide range of topics, including some of those listed right there. All right, so I will stop sharing, Bill. I think you should be able to share now.
Okay. Here's the SSDAN homepage, of course, which you've seen. And what I'm going to do is demonstrate a little bit about what we have on our data count site, which is what you've been using in your breakout session and dealing with Jill's module. And so we go on data counts, and this is our data count site. There's a kind of a menu there of the different kinds of data sets we have. And I'm going to go right into WebChip, which of course is the program that we're using to access all these data sets. I'll come back and talk about other things on this site a little bit. But as you may remember, when you access the data set that Jill had you use, you had to first go to a collection. We have several different kinds of data set collections here. The ones are separated. We have main collections. You see, we have very big collections from back in the 2000 census when we still had the long form. The ACS for 2010, and we have a few subsequent ones coming up. 2016 trend data, which we're going to use in a little bit. We're actually going to update the main collection in the next year, probably preliminarily with the 2019 ACS, but then definitely with the 2020 ACS to correspond with the 2020 census, which, as you may know, has been delayed in its release due to the pandemic. So that may take a little while. We also have state level data for several years at this point. You've used some of that in your analysis with Jill's thing about earnings. She used Kentucky, you used another state. We have single year data. Now, these data aren't as voluminous in terms of how many data sets we have. For example, the 2017 data set has only a few variables: education and earnings, education and employment, households and poverty, marital status, Pop USA. Typically, all of our data sets are disaggregated by age and race, but then have something else on them. As JP just mentioned, our idea here is not to have students go through like a data set with hundreds of variables. That's just too confusing. I mean, if you did that, I mean, I know a lot of people use this. They use SAS, they use SPSS and statistical programs, and that's fine for students who've had some experience with data analysis. But for the very first time, you don't want to overwhelm them with lots of variables and lots of categories. So it's your job as the instructor to figure out which data set has the right combination of variables to use in the kind of course that you're teaching. And we try to provide a large array. As I said, this particular one-year data sets are relatively small in the number of variables that we have, but the advantage is that they're going to be for each individual year, and we're soon updating them from 2018 and 2019. They're very close to the end of the assembly line, but you can see that those are there. And then we have these other collections, and one of the ones we're going to use today is the ACS 2018, which will be expanded even further with 2019 coming up very soon. But what I wanted to do is show you another example, just to give you a feel for another kind of data set, and that's a trend analysis. And I'm going to pull up this ACS trend collection. Now, once you pull up the collection, then you can see what data sets are available for that collection. Now, these are coming from 2016 to 2016 ACS, and we have different collections of data sets in here. What I'm going to pull up here is the one for households. Now, this household data set has the year. That's the trend analysis. It tells you which year you're doing to, as well as race, age, household type, and household size. You can look at the marginals here. You can see in this one we have the data going back to 1950. So we have census data from 1950 up through 2000, and then ACS data for 2008 and 2016. For the longer term data sets in the trend analysis, we only have black and non-black for reasons that, in order to make this more statistically, in other words, the other kinds of categories were more difficult to make precisely the same for years going back to 1950. So we have them in that way. We have age, we have this household type, which is married couple, female-headed families, male-headed families, families with male householders, families with female householders, and then male and female non-families. Most of those male and female households are single, non-families are single person households, but some of them have unrelated households living in them. So the main family types. We also have one on household size. So one of the things I want to do is first, let's look at the idea that this is trend data and check to see how household types have changed between 1950 and 2016. Let's do the row variable as household type. Okay, household size, let's make it household type. And the column variable, which in this case is the dependent variable, household type, we're going to make this a row variable. I think, as Jill mentioned, some people have a strong preference. They always want the dependent variable to either the column or either the row. Other people want it the other way around. This way you can decide how you want to do it, because you can percentage each way. You can put any variable in each, either as a row or column. In this case, though, we're going to have the dependent variable as a row, the independent variable as a column, which will make year. And since we want to look at household types, how the percentages of household type differ across years, we're going to percent down as I get through this thing. Okay, so if you look at this, you can see that, married couple households were 77% of all households in 1950. But when we move up to 2016, it's less than half of all households. On the other hand, if you look at these male non-families and female non-families together, they were only about 12% in 1950. And we move up here to 2016, and they're 34, 35% of all households. We have more people living independently, less with husband and wife with kids. An interesting feature of this is our graphing opportunities. So let's look at these differences in terms of stacked bars. What this shows us is for each year, the percentage distribution of household types. And then if you hover over, you can actually see those percentages. Again, married couples are 77%. It's the dark blue are the marriage couple percentages. And you can go down here to 2016 where they're only 47.9%. You can see the bigger shifts towards non-family households. Again, a lot of them are living alone as we move over time. You can see a big jump between 1970 and 1980. You know, this is a period where a lot of baby boomers who were, you know, getting into the labor force, and a lot of women in the labor force and so forth. And the married couple with household segment of the population was going down disproportionately during the 70s, but then continuing during the 80s and downwards. So this is kind of something you can visualize. We have other ways of visualizing this too, but for this one, it looks like the best. Supposing we want to look at to see how this differs by race between blacks and non-blacks. In this case, we're going to look at the control variable, and we're going to pick up race. And we'll again percent down, and up pops up two tables. First for non-blacks and the others for blacks. For non-blacks, it goes from 78% married couple households in 1950 down to just 50.8% in 2016. But for blacks, it goes from 65% rather than 78% down to 27%. So if we look at these in terms of the stacked bars that pop up, this is the non-black one. Again, this kind of big shift between 1970 and 1980 and going further down. And where the bigger change is this increase in non-family households, headed male or female non-family households. But for blacks, which was lowered married couple share to begin with. Over time, the female-headed family among blacks became the bigger part of the household structure for the black population. But in the last really since 2000, that's big, but it's come down a little bit, whereas within the black population, there is an increase in the non-family households for both male and female-headed non-family households. But again, a dramatic decline in the sort of traditional family married couple households. So that's one kind of exercise you can do with this trend analysis. Of course, if you're doing the trend analysis and you're using these data sets, you really need to put year in either the row or the column or in the control variable to take advantage of the fact that you have all these different census data put together. But we've tried to put it together in a way that makes it easy to do trend analysis on a number of these topics. Now, of course, you can clear the workbook by just going like this. Makes everything go away. I want to go through another one here and use a different data set. I'm going to use our 2018 5-year data set. And of course, Jill took us through the earnings differences between men and women and by race. In this case, we have a separate data set up here for lawyers. We also have one for doctors that we can put up at another time. So what's happening for male-female earnings among lawyers, not just in the population in general, but among lawyers? We look at these marginals. We have the age group, we have race, we have earnings, and we have male and female. 63% of lawyers are men, 36% women. And what we're going to do now is look at the, here we're going to make the dependent variable a column variable. So we're going to do sex as a row variable and earnings as the column variable. We're going to percent across. And just as with the population in general, male lawyers make more than female lawyers. 19% of them make over $250,000 compared to 9.8% of women lawyers. Let's just look at a different kind of a chart here. Let's look at the bar charts. These bar charts show for each, it's a percent distribution across different income categories or earnings categories, where for males, the really high earnings group sort of stands out. The really low earnings group kind of stands out. But for women, you know, it's more sort of steady across those different categories. Now you might ask, well, maybe is something changing over time? Is it maybe the younger cohorts of women, you know, are doing better? Maybe it's only these older generations where men were doing so much better. So one thing we can do is control this whole thing by age and do the percent across again. So it pops up all the same table for all these different age groups. So I'm not going to go through all of those, but instead I'm going to do the bar charts for them. We'll go through the bar charts here. Come on. This is, whoa. I'm getting here.
Bill, I think there's another scroll bar on your right.
Okay, you're right. Thanks, JP. Anyway, here are the 25 to 34-year-old lawyers, and they look pretty much the same. The men on the left, the women on the right. So this may tell us something about how a newer generation of lawyers, the gender difference in earnings is not so bad. But as we move up to the 35 to 44-year-old group, that's like the older baby boomers, sorry, the older millennials and a bunch of Gen Xers in this group. And then we see the male lawyers starting to pull ahead at this high income place, a little more than the women lawyers. And we get to the 45 to 54-year-old group, and the men lawyers really pull ahead there, the very highest income group. And then the 55 to 64-year-old lawyers still pulls ahead there. Sorry, 65 and over is a little hard to interpret because of retirements and so forth. Anyway, this is kind of just a very simple example of what you can do with the charts and doing something like this. We have lots of different other data sets, and we're constantly updating them. And we're going to do a lot of updating in the next year, as I say, with the 2019 ACS and the 2020 ACS. I just want to show you just a couple more things about what's on the Data Counts website. And that is we have modules. Now, Kathy mentioned that you can, pull down a lot of our modules on lots of different topics. I'm going to go, you can actually sort them by lots of things, but we're going to sort them by year of most recent creation. And here's one that's called Give Racism a Chance. Actually, on this one, doesn't use our Data Counts data at all. We actually have some stuff on there about segregation indices for metropolitan areas in the United States. So if that's something you're interested, you might want to go to that one. But we have lots of other things, including Jill's module that you just went over in the first part of the webinar, and lots of other kinds of modules that you can just go through, and you click on it, and it has all kinds of information about the goals of the module, how you use it in class, what data sets are used, and that sort of thing, which are available. So that's one of the big advantages of our project. And we're constantly collecting modules. And if you would like to submit a module, there's even a click on option here for you to sort of click on that and fill out all of this. Of course, we hope that you have this tested in your class, that you've tried it out in your class. All of our modules have been course tested and class tested. This is a way you can share them with other people who are using our website, and we very much appreciate that. We have something on frequently asked questions here as well. So I'm going to go back to our homepage here and just let you know that we're always updating it with announcements about what's going on. Census Bureau had a boundary and annexation survey. You can read about that if you want to. We have tweets coming up all the time about various different things. And then I want to introduce you to one other sort of sub-website we have that's part of our project. It's called the Programs in Population Sciences, the PIPS website. You can get on it from right here. And this is a way, if you have students that are really interested in going into the field of demography or population studies, we have a listing here of all the main population programs around the major universities around the country. With information about each one, starting out with Arizona State, Bowling Green, and so forth. Penn State, University of Michigan, University of Minnesota. I think we have some people here from Minnesota on our group today, and you can read about the University of Minnesota Population Study Center right there. We also have on our website dates when applications are due for various kinds of programs. It turns out March the 18th, Columbia University, Masters in Sociology, something going on today. April 15th, the City University of New York, Quantitative Methods in Social Sciences, and also for various kinds of internships we put on here as well. So if you have students who are interested in demography, there's a lot of stuff in here, in addition to other profiles and so forth, various kinds of opportunities. So I urge you to look at that as well. So that's a little bit of an overview of the SSDAN website and some of the things that are on there. We're always interested in suggestions. We're always interested in contributions. So please do that when you have a chance. So I'm gonna leave it open now for anyone else to join in if they want to.
Yeah, so we have a few minutes for questions before our break. Are there any questions for JP or Bill? So if there are not any questions, I think we'll go ahead and start our break a little early. That way we can get back and have more time for Esther. So I have that it's 3:47 and we'll start back at 3:57. So we'll see you back at 3:57. So I think we're now turning it over to Esther.
Kathy, before we do that, was there a question that you wanted answered?
Yeah, there is. Esther was going to ask it, but if you look in the, that's
sure.
okay. That's okay. If you look in the chat box, we had a question that came in right at the end of our last session from Kurt.
All right, I'll take a stab at answering this. Kurt asks about, for intermediate level classes, is there something in between the web chip type data sets that we provide and data counts and downloading the entire PUMs from the Census Bureau's website, or using something like R and the webinar resources that we discussed before? I have a two-part answer. One is that I believe Esther will be presenting on something that is a great intermediate product that I think is great for those students who've kind of worked past something like WebChip. But what we have at least discussed internally at SSDAN before, and what we've done a little bit of, is actually made some of the repackaged data sets available in for use in statistical packages. So I put a URL in the chat that goes actually to a workshop that we gave in 2017, where we actually provided some of these sorts of data sets. They can be quite large. So if you wanted to look at the full respondent level data set for something like earn.dat from the 5-year ACS, it's what is it? About 500 megabytes for SAS. We've also discussed putting something like Bill mentioned, the lawyers data set. If we were to put something like the lawyers data set, that is going to be much, much smaller. It has a much smaller universe. So that is something that I think is in the order of tens of megabytes. If those are of interest, please get in touch with us. We'll provide our emails at the end of the webinar today. Please feel free to get in touch with us. We can probably provide some of those to you. We actually create small repackaged data sets in SAS as part of our workflow to create the data sets that end up in WebChip. So with that, I will hand things off to Esther.
So hello, everyone. And I'm really glad to be here. And as JP said, my name is Esther Wilder, and I'm a faculty member at Lehman College, which is part of the City University of New York. We're a minority serving institution in the Bronx, a Hispanic serving institution. So I think a lot of the activities I'm going to be talking about today are really activities that I think are really helpful for teaching students who are sometimes a little scared of data analysis and unfamiliar with it. So I'm really teaching to a student population that often has not had a lot of experience doing data analysis. So the activities that I've designed are really geared for those students. But as JP said, some of the stuff I'm going to be showing today represents maybe a little step of a higher level of sophistication in data analysis than the materials in the SSDAN website, the web chip materials. So I'm going to be talking about that, but all of this is within the context of a discussion about assessment. So that's what the topic of my presentation is about quantitative reasoning assessment. And within the context of that discussion of assessment, I'm going to give you a little introduction to some of the work I do with census data, or particularly working with the ACS, the American Community Survey. So I'm going to get started to tell you a little bit about what I hope to accomplish in this brief presentation. And like I said, then I'm going to be guiding you through some hands-on activities that I hope you all will enjoy. So to begin with, I just want to provide a little bit of an overview about assessment. I'm sure everyone in this room has some sense of what assessment is. I also want to talk about how I visualize or think about assessment when I teach my classes, because it may be a little different from how some of you are thinking about assessment. I know there's a lot of pressure on faculty. There's this kind of administrative pressure to undertake assessment, and it becomes kind of a requirement. And a lot of faculty have kind of recoiled and turned against assessment. But one of the things that I've been trying to do in my own work, and also in the faculty development work that I've been doing, because I do a lot of faculty development, is getting faculty to embrace assessment. Then I want to talk a little bit about some strategies for undertaking assessment. And then, like I said, I want to do some hands-on work. I want to show you an example assessment that I have for my class, and I also want to do some work doing some hands-on work. So just a little bit of background. I've been working now with Bill for a long time, and Jill and Kathy and JP, this entire team of us, we've going back for more than a dozen years. And I just want to say, I started off all this work when I attended a workshop at the University of Michigan, and I think it was over 15 years ago now. And since then, my career has really been built around a lot of this work on pedagogy and figuring out ways to improve students' data analysis and quantitative reasoning skills. And fortunately, I've had a lot of support from the National Science Foundation for the work I've been doing. So a lot of the work I'm talking about has been a product of some of those grants where I have actually been training faculty in best practices for quantitative reasoning instruction. So let me tell you a little bit about some of the work I've been doing and how this applies directly to assessment. So first of all, what is assessment? Well, assessment, here I have a definition for you from Linda Susky, which defines it as systematically gathering, analyzing, and interpreting evidence to determine how well student learning matches our expectations. That's directly from her book on assessment. As you can see from this picture, I have a little image that says assessment is the engine that drives learning. I think assessment is critical. And in the presentations we've heard today already, Jill talked a lot about how she uses assessment in her own teaching. I know Jill talked about assessment. Kathy talked about assessment, and Kathy mentioned how assessment can be both attitudinal, it can also be cognitive. And I think both approaches are really helpful when we want to evaluate our learning that we're seeing happen in the classroom. So the important thing about assessment, though, is that we use assessment to improve our teaching and to ensure that we're achieving our student learning goals. So I think assessment is something that if we care about our students and we care that our students are learning, then we care about assessment as a strategy to determine whether or not we're being effective. Because we all come in with these built-in biases where we assume that what we're doing is working and what we're doing, makes sense and it's a good approach. But assessment is a way to really systematically test that approach and to see whether or not what we think we're doing and whether it actually is working. And it's a way to kind of engage in a scientific process of methodically analyzing whether or not we're achieving our learning goals. So, continue here. Okay, so there are different levels of assessment, and I just have a diagram here. Assessment can be undertaken, at the level of the nation. Of course, even it can be undertaken internationally. There are some assessments that are undertaken internationally. It can be taken at the level of the institution, a program of studies. It can be like taken at the level of the department, or even at the level of the lesson or assignment. And the assignment that Jill did provides a nice illustration of how she actually undertakes assessment at the level of the lesson or the assignment. I think a lot of us who are faculty members are getting pressure from administrators to undertake assessment for our departments and to have this data reported back to, sometimes it's accrediting agencies such as Middle States or whatever your accrediting agency happens to be, where you happen to be located. But what we want to do in the way we approach assessment is take assessment as something that we're going to use for ourselves. When I talk about assessment in my faculty development workshop, I don't want the assessment to be something where faculty are feeling like, you know, they're going to, any of this assessment data is going to be used to evaluate their teaching, or it's going to be taken away from them, or someone's going to be looking at. I want them to be using the assessment for their own purposes, for their own interest in terms of seeing whether or not they're achieving learning goals. So one thing I want to emphasize is the distinction between grading and assessment. And sometimes I think when I talk about assessment, a lot of faculty think, well, I'm grading my students, that, you know, they're getting A's, so that shows that, you know, I'm doing well. Well, assessment is a little different, because I think when you're doing grading, you're basically trying to give information back to students and give them some sort of assessment of how well they've done on these assignments that you've designed. But there can be a lot of factors that influence grading that aren't necessarily related to student learning. So sometimes you have things such as, you know, whether students are coming to class, and there are all kinds of factors that can influence, you know, grades that aren't necessarily directly related to student learning. And when you assess student learning, you're getting back more specific information about the specific goals that you're trying to achieve. So assessment, I say, is really designed to give information back to instructors about whether or not you're achieving learning goals. So when you're grading, like, again, your audience, really your target audience is your students. And when you're undertaking assessment, I think your target audience should be yourself, that you're gathering information for yourself. Sometimes you can have graded assignments that can be used as assessments as well. But a lot of times when I do assessment in my classes, I'm not doing any kind of grade for it. I'm just getting the information back for myself. And especially, I think, as Jill showed with some of the questionnaires that she undertakes at the end of her semester, where she's basically getting this qualitative feedback on how students felt about the assignment, that is an example of assessment that is unrelated to grading, of course. Okay. So there are all kinds of ways people can undertake assessment. You can have things such as surveys, questionnaires, portfolios where you collect assignments and all kinds of materials, written work that students have done over the course of the semester, embedded course assignments. You can have all kinds of certain kinds of tests, such as multiple choice tests, assignments with rubrics, where you look at whether or not they have fulfilled all the requirements of the rubrics. And then you can also just have assessments that are student reflections. And like I said, sometimes you can have overlap with a assessment for students and assessment for your own goals, but I think in many ways it can be helpful to keep them distinct. So the assessment cycle is outlined here. And basically, it includes kind of 4 different stages. And this is basically, I call it the assessment cycle. You can also call it the learning cycle. It's basically a model of best practices for how to promote learning. And the first way is basically to start with, you know, specifying what you're hoping to achieve. What are your learning goals? And after that, of course, you want to provide the learning opportunities. You want to provide assignments, instructional materials that will achieve those learning goals. And then I think the important thing is really to assess whether or not you achieve those learning goals. And when you get back the assessment data, sometimes you'll find, well, you know, it was successful, or maybe it wasn't successful. And you may want to tweak your assignment. You may want to tweak your learning. You may want to tweak your lectures or whatever you're doing to promote those learning goals. And then the process repeats itself anew. I think it's kind of to think of it as an iterative process, as an unending process, in which you're always trying to ensure that you're working towards, you know, the best you can be in terms of achieving your goals. And I always say for me, it is constantly a process of refinement. I'm never going to be there. It's sort of like something that, is this goal that, you can never really achieve. It's the goal of being the perfect instructor is never something that any of us achieves, but we all can always be improving. And I say myself personally, I always am trying to improve. And one of the things I also love about attending these workshops with Jill and with Kathy is I've learned so much from them over the years about how to improve my own teaching. So I really am glad to be a part of this group. Okay, so let me just get hands-on into, what I'm doing in my own teaching and how I'm assessing my own teaching and how what I'm actually doing to achieve my learning goals, focusing specifically on quantitative reasoning and using the census and ACS data, which is the focus of our workshop today. So I teach a variety of courses at Lehman College. My background is actually in demography. I know there are a lot of demographers here today, but at Lehman College, I typically teach courses in health and disability. I also teach a course on death and dying. And I structure my course on health and disability as really a hands-on kind of data analysis course. The course is actually called Social Science Perspectives on Health and Disability. And in the course, I do a variety of activities where the students are actually engaging in hands-on data analysis. In addition to having them work with census data and with the American Community Survey data, I also have them engaging in an activity where they actually design a survey and analyze the survey data. So out here, I've outlined some of my goals that I have for my students. And one of the things I say when you think about, well, ultimately, you're going to be assessing your learning goals. So you want to start with articulating, what are you trying to do with your students? Okay, what are you trying to do with the assignment? What are you trying to do with the class? Of course, on the class, you usually write what your learning goals are for the class on your syllabus, right? But I think it's also helpful, as we've seen with the modules that Bill has talked about and which Jill has talked about, to specify what your learning goals are on those specific assignments that you give to your students. So I have an assignment where I have students working with IPUMS data. And right here, I've outlined some of the goals of that assignment, okay? So what I hope to do with the assignment is I want them to be able to distinguish between distributions and rates, okay? So I want them to understand the difference between, if you have a distribution of the population, say, for example, if we were to look at the distribution of people in poverty, and we were to look at, well, if we look at all the people in poverty, we would find that, for example, the majority of people in poverty in the United States are white, just because of the fact that most people in the United States are white. But if we were to look at rates, which would be a different base population rather than the total distribution of people in poverty, we would look at the number of people in each group and see what percent of them are in poverty. We'd find that the rate of poverty among whites is lower than the rate of poverty among underrepresented groups. So for example, among Blacks or among the Latinx population, okay? So I want students to understand that. I know this is something that was mentioned in some of the earlier presentations, but another thing that is really important is that students will understand the distinction between row and column percentages in making a bivariate table. That the base population, if you switch rows and columns, changes, and that has important ramifications for how you interpret the data and what the data are telling you. I find that my students have a lot of trouble understanding this. Even with the work I'm doing, I make some progress, but I'm still figuring out ways to do this better. So I always welcome feedback from all of you as well, if you have figured out a good way to do that. Another thing that I want my students to do is to be able to prepare and interpret pie charts and stack bar charts. There are a lot of ways to represent data. There are line graphs, there are pie charts, there are bar charts. There are all kinds of ways to represent data. I want them to be able to figure out how to represent the data. What is the best way to represent the data? If you have, time series data, do you use a line chart? Do you use a pie chart? Do you use a stack bar chart? I want them to understand, with time data, you want to represent the data in a linear fashion with a line chart, those kinds of things, and when to use the best what is the best graph for each set of data. So in my assignment, what I do is I have a pre-test and post-test. And what I've been doing over the years is I've approached assessment in many different ways. Since, as I mentioned, a lot of my work has been supported by NSF. Sometimes I've had very involved assessments in my classes because I've been trying to assess a variety of different skills and a variety of different attitudes. So I've had an assessment at the beginning of the semester and at the end of the semester focusing on attitudes and everything. And by the way, as you see at the bottom of my slide, it says that my material is from the Numeracy Infusion Course for Higher Education, or niche. This was a faculty development program that was supported by NSF. And if you go to our website, there are a lot of examples of assessment instruments, some of that were developed as a result of that project. So maybe I'll show you that later. But anyways, if you go to the website, and maybe Kathy, you can just put this in the chat. The website is www.teachqr.org. And it has a repository of assessment materials. It also goes over a lot of the material that I'm talking about today. So in addition to having like a pre-test and post-test at the beginning and end of the semester, I like to do little assessments throughout the semester even for specific assignments, as I do for this one. And one of the things I think is really important when you develop an assessment instrument is to keep it simple, make it something that you'll definitely use. Because I find that sometimes faculty, especially even in the workshops I lead, they will develop very complicated assessment instruments, and then they end up coming away with this really complicated assessment instrument that takes a lot of time, and they never use it. So what I think is important to do is to develop an assessment instrument that you'll use and that will provide helpful information to you. So what I've been doing in my classes with this assignment is I basically developed a very simple assessment instrument that gets at some of the information that I'm trying to achieve, okay? It doesn't get at all of my learning goals, but it gives me some information. So what I'm gonna do is I'm gonna show this to you, and we're all gonna just participate in this. If you go to this link right here, and Kathy's going to put it in the chat, you can all click on it and I'll show you it. And you can all just fill out this assessment instrument. And I just put this in a Google form, which is nowadays, since we're all teaching online here at the University of New York, we're completely online for this semester, as we were last semester. And we actually are going to be teaching online again in the fall. So I'm moving a lot of my stuff to the online environment. And in the classroom, I used to do this using clickers. I had a set of clickers that I would distribute to my students. So now, since we're all doing everything online, I'm putting everything online. So here I can see the responses. So I have 3 responses to my assessment. So if everyone could just take the time to complete that, that would be great. And one thing, a lot of times now I'm teaching actually in a synchronous format. So I'm teaching online, but like the same way we're having this workshop, I'm teaching with my students being present. And one reason I really like, things like Google Forms is I can get my feedback immediately. You can also do that with the polls that Jill was doing earlier in our workshop. But anyways, as you can see here, let's just talk a little bit about this. This is a distribution of individuals in the United States with an independent living disability by race. This is from the American Community Survey data. And I just made this chart. And basically, I teach a lot about disability. So this shows the distribution of individuals living who have living disability by race. So it's the distribution of people all in the United States who have an independent living disability. So they have trouble living independently. That's one of the questions on the American Community Survey, whether people are able to live independently or whether they have difficulty doing tasks such as shopping and going out. So what does this chart show? Well, if you look at this chart, it's just basically a pie chart of the distribution of people who have an independent living disability. And I ask which of the following is true. Is it true that 3.8% of Asians have an independent living disability, or whites account for 3/4 of individuals with an independent living disability, with independent living disabilities, or among all survey respondents, white respondents were more likely than other racial groups to indicate here, it got cut off because I'm in edit mode, to indicate that they had an independent living disability. And just so you know, this chart here basically is showing, let me just see here. This chart here is basically showing the distribution of people with independent living disabilities. So which of the following is true? The answer that is true is just one of them. It's only that whites account for 3/4 of individuals with independent living disabilities. Just want to see. So I just, okay. So the answer here would only be this one, that whites account for 3/4 of individuals with independent living disabilities. These both are incorrect. It's not true that 3.8% of Asians have an independent living disability, and it's not true that among all survey respondents, whites were more likely than other racial groups to indicate that they had an independent living disability. Now, the reason I ask this question, because this is getting at one of the skills I'm trying to have my students understand, the difference between these base populations. This is the distribution of people with independent living disabilities, okay? Of all the people with independent living disabilities, the overwhelming majority of them are white, just because of the fact that there were so many more whites than other groups in the sample. However, if we wanted to look at the rate of whites who have independent living disabilities, we would have to, our base population would just have to be all whites, and we would see of all whites, what percent of them actually have an independent living disability. So if I go here and I look at the responses to the question here, as you can see, based on the distribution here, the only thing that was correct was that whites account for about 3/4 of individuals with independent living disabilities. So even among this sample here, it looks like 40% of the faculty and administrators and everyone in the room, grad students and everything, got this correct. So most people did not get this correct. So this shows to me from this assessment that I have my work cut out for me. I have to make sure that people understand why this is, this is not the case, okay? So again, if we go back, to the question, and I look at the question here, this is the distribution of people with independent living disabilities. Just the same way, if we had the number of people in poverty in the United States, we'd see that most of them are white, but it doesn't tell us that they're more likely to have independent living disabilities. This doesn't tell you that 4% of Asians have an independent living disability. This tells you that among all those with independent living disabilities, approximately 4% of them are Asian. But we would need a different base population if we wanted to say what percent of Asians have an independent living disability. So let me show you a little bit about, well, how do I go about trying to teach this, okay? And why, and this also speaks to the importance of when you see a graph, like seeing a pie chart, you really have to sit there and study it carefully. Because this pie chart, I tell students, we go over how to interpret tables, that this is the distribution of individuals with an independent living disability by race. Look at what the pie chart is telling you. This is a distribution, okay? So make sure when you interpret it, you look at, what is this telling you about this distribution, because that's what it is, okay? So going back to my presentation, I'm going to show you a little bit about how I go about teaching some of this stuff about pie charts and stacked bar charts and how to kind of make sense of the data. Okay, so since we're doing a presentation on working with the ACS and working with the census data, I'm going to show you some work I do in my classroom working with these data. And what I'm doing today is basically just a snippet from my assignment. So it's not the whole assignment where I do try and achieve all my learning goals, but it kind of gives you a picture and hopefully an introduction to how you might use some of the microdata, analyze some of the microdata from the American Community Survey. So if you follow my instructions here, Kathy is putting this in the chat. So you're going to see the link in the chat. And I'm going to kind of quickly go through this, how we might, look at some data. If you go here to the IPUM's website, you do need to log in. So what I've done here is I provided my ID and password. I'm just providing this for the purposes of this workshop. I strongly encourage you to create your own ID and password. It takes a little bit of time. And since we're kind of limited in time, I just wanted to give you some guidance to make it a little easier if you don't already have an ID and password. If you have an ID and password, that's great. So you can just go ahead and do that. If you don't already have one and you're just learning about this for the first time, you can go ahead and use mine. Like I said, I'm just creating this for the workshop. I know there are a lot of people from University of Minnesota here today, and the analysis that we're going to be carrying out, it was developed, it's being held now at the University of Minnesota. So I just want everyone to be aware that this is just a small exercise for today, which is why I'm sharing this, okay? So what I'm going to do is I'm going to go to it here. When I go to it, this page comes up, okay? And like I said, if you are new to this, there's going to be a little, I'm going to click on here. You want to go to IPUMS USA because this is where you're going to find the census data and the American Community Survey. So you can just click on here, visit site for IPUMS USA. And there's going to be here, you see at the top, it says, welcome, Esther. It knows I'm already logged on because I've been logged on today. But if you're new to this, it's going to ask you to log on. So I just want to give an opportunity for people who are new to this, if they want to log on. Again, my ID and password is in the chat, or if you have your own ID and password already, you can go ahead and access that. Make sure everyone has time for this. So once you log on, okay, you should be at the IPUMS USA page, okay? And IPUMS is, these are the microdata. And basically, we're going to use an online tool for data analysis called SSDAN, which stands for Survey Documentation and Analysis, which is a nice user-friendly online tool for analyzing data from the census and the American Community Survey and some other data sets as well. And it's very user-friendly. You don't need to install any special software on your computer or anything. So it's similar to what we were just watching Jill do with WebChip, but it has a little more sophistication, as I'll show you in a minute. So you can click on Analyze Data Online here, where you see online tools for data analysis. Just click on Analyze Data Online. And then if you scroll down here, you see a wide range of data sets, okay? And these are some of the data sets you can use. So you see going back many years, such as to 1850, the 1% census going back there. It has data all the way up to 2019. It's constantly being updated. So soon they'll probably have the 2020 ACS. Okay, or here they have the, they have the 2019 ACS here. And what I'm going to suggest we work with today is the 5-year ACS from 2015 to 2019. I know JP talked a little bit about, why it can be better to use sometimes the 5-year intervals. You have less noise in the data. So what I'm going to do here is I'm going to select the 2015 to 2019 5-year ACS. And when I do that, what I get here is kind of an interface for analyzing the data. And it's actually very user-friendly as well. It has a little more sophistication, which I'll show you in a minute. As you can see at the very top, you can do some more advanced statistical analysis like correlation matrices, regression, logit probit analyses. So if you're looking to do more advanced statistical analysis, you can do that. What I do, since I told you all, I'm teaching a course on health and disability, and I'm really just interested in having my students do some fundamental descriptive statistics. That is what I'm trying to do. But I want to give them a little bit of flexibility in some of the data that they might want to analyze. So what I do in my class is I have them make comparisons about disability by race and ethnicity, or by Hispanic origin, because the census and the ACS, they treat whether or not race and Hispanic origin as two separate variables. So I let my students pick which one of those they want to use. But basically what I'm going to do for purposes of illustration is to show you how I do it using race and ethnicity. So once you have this interface here, you see all these variables that are included in this 2015 to 2019 ACS data set pop up here. And I'm really interested in disability. So I'm going to click on this disability variable. You see there's a little arrow right next to it. So I can click on it. Okay. And then these are all the disability questions that were asked in the American Community Survey. And if you go back here, okay, if I go back to my presentation here on the next slide of my presentation, I'm going to tell you a little bit how to analyze the data. But one thing, if you look at my slide here, I say you can find a copy of the ACS here. As I mentioned, I teach a course on disability. And one of the things I like to do before I even start analyzing the ACS with my students is say, let's look at the ACS. What are the questions they ask? What are the specific questions they ask about disability? So if you go to this link here, you can actually see the ACS and you can see the questions that were actually asked. And what I do in my class when I teach about this is I often go to the ACS and say, well, here's the ACS. I'm sort of limited in time, so I'm not going to do all this right now, but I say, well, here's the ACS. Let's look at all the questions on disability. And this is very helpful, not just because I want them to analyze data, but I want them to think about how we construct this category disability in the United States, because that's really important. I'm teaching about the sociology of disability and actually looking at, the census or the ACS to just think about, well, how are these categories constructed? They're social constructions, of course. How do we measure disability? We talk a lot about that in my course. So we actually talk about, well, how do we want to measure disability? Okay. So going here, sorry. Now, if I come back here to, the data, once we've looked at the ACS, we see all these questions about a cognitive difficulty, about an ambulatory difficulty, about an independent living difficulty. So we actually get to see what were the actual questions that people were asked. And I think that's really helpful for the students, because then they say, well, okay, we asked, basically, do you have the question on vision difficulty is something about, do you have a visual impairment that cannot be corrected with glasses, okay, or contact lenses? So we see, okay, and now here's our question. The same thing about hearing, okay? So I'm going to select the hearing question, okay? I just click on it so I can get the question. When I click on it here, it pops up here for selected. And if I want, I can just view it and it will show me the frequencies, like the same thing where we did the marginals on the last question. If I go here, I can click view and I can see, how many people in the whole sample here said, no, they don't have a hearing impairment. This is, 95.7%, 4.3 said yes, okay? So I can just view the frequency very easily, okay? But what I want to do with my students is I want to make a comparison. So what I'm going to do with the difficulty hearing is I'm going to put it in the row, okay? And then what I'm going to do to make my comparison here is I'm going to put race here in my column. So I'm going to click on race. And then what I can do here is I just go up here and select column. And then it puts it here. by the way, you see here how it says difficulty hearing, diff hear? That's the name they gave to the variable for difficulty hearing, for having a hearing impairment. If I scroll down here under disability, you see it says diff hear for hearing difficulty. You can actually just write that in. You don't even need to click. If you want, you can just go to row and write difficulty diff hear. Then you just make sure you have the right name. Or if you go up here, actually there are two race variables. There's race D, which has more categories, and race here, which is a little more simple. I'm going to just select actually race. You can get rid of the D. If you click on them and do view, you can also see exactly what they both include. But now I have difficulty hearing as my row variable and my column variable. I have race. And now basically I can just run the table, okay? And by the way, there are chart options here. So you can say like the default here, it's going to give me a stacked bar chart, but you see where it says chart option, I can change it to a pie chart if I want. For now, I'm just actually going to run it as a stacked bar chart because that actually is the best way to represent the data. But as I do that, I can go run the table. And here I have my data, okay? So here, basically, if I look at these data here, okay, and I basically, have a nice chart here which shows the distribution of hearing difficulties by race. And basically here, it has it broken down by each of the categories that are used in the census here for this category, for this variable race. And again, Latino origin is treated separately, or Hispanic origin, that's a separate question. That's why you don't see that in the race categories here. But you see it has white. So you see, for example, among all these groups, you see that 4.2% of whites have a hearing disability. About 2.2% of Blacks or African Americans have a hearing difficulty, and so on and so forth. Sometimes these results are kind of counterintuitive because a lot of times my students assume, for example, that minorities would definitely have higher rates of this disability than whites. And here we see, for example, that Blacks actually have much lower rates. And we talk about some of the reasons this might be the case. So for example, the fact that hearing disabilities develop in later life, and minorities are less likely to live as long as the dominant group. So we talk about some of these explanations when we go over this, but the main thing is I want my students to be able to look at these data here and make sense of them and say, well, when we look at the whites, how do we interpret this? And I actually have my students write about this and say, for every 100 whites, okay, and this is from 2015 to 2019 on average, approximately 4 of them have a hearing difficulty. And the same thing for these other groups, okay? So as I said, I want them to understand the difference between rates and distributions and row and percentage columns. So what we do next is, one of the things that I do next is I reverse these, okay? And if I put, and I'm just going to retype it here, if I write difficulty hearing here, and I write race here, okay, I put race in my row variable. Usually I would say for students, and this is talked about in some of the earlier presentations, in the row variable, you typically want your dependent variable, what you're trying to explain. And so we're trying to understand, why people have disabilities. So here we're kind of reversing things around. If we put race in our row variable and difficulty hearing in our column variable, we're switching things around. And the default with SDA is that they add the percentages in the column. So when I run the table this time, okay, and I'm going to do the same chart, just the same stacked bar chart here. When I run the table this time, rather than having difficulty hearing as my row, I have race as my row, and I have difficulty hearing as my column variable. When I run it this time, it's going to look very different, okay? So now what I do here, okay, when I do the columns the way they add up now, okay, if we look at who has a difficulty hearing, okay, what we find here is that we're looking at the distribution of people who have a difficulty hearing now by race and ethnicity, which is very different from looking at, the rate of having a hearing impairment for each separate racial and ethnic group, which was what I was doing last round, okay? So for example, okay, if we look at this, when we look at the percentages here, the percentages now total to 100 based on whether they don't or whether they do have a hearing disability. So like the same thing I showed you with the pie chart, okay? This number here, which shows you 83.4%, this shows you among all people who have a hearing impairment or a hearing disability, 83.4% of them were white. Okay, so the overwhelming majority were white, of course, but this is a reflection of the fact that most people who responded to the ACS were white. Okay, so I want people to understand, and like I said, I'm kind of doing this quickly because I have about 15 minutes in class. I'd spend a whole class period going over this, but I want them to understand these distinctions, okay? And we go over the graphs too in more detail, and I actually have them make their own graphs in class, and I work with them going through this whole process. So we're kind of doing an expedited version of what we do. One of the things that I just want to mention when I make the charts, one of the reasons we look at the ACS and we studied it carefully is for some of these questions, for example, from the ACS, such as an independent living disability, they were only asked of a subsection of the population. I think it was people 15 and over, and an ambulatory difficulty was only asked of respondents ages 5 and over, because of course, babies, they all have ambulatory difficulties. So some of these questions, when you add these questions, you have to add a selection filter. And that's why I'm saying it gets a little more complicated. Hearing difficulty was asked of all respondents, but if I were to do something such as an ambulatory, if I were to do an ambulatory disability, and I'm going to add that to my row, and I'm going to make race as my column variable here, I need to make sure I add a selection filter. And because it was asked of people only ages 5 and over, I'm going to make it, you can see some of the selection filters I've already used, they pop up. I'm going to make it ages 5 to 125. So you see, it's a little more complicated. There's more versatility, what you can do than WebChip. But I think it's still a really, useful tool. And my students do get a lot out of it. And then I can just run the table for this. If you don't run the table with the filter, you get a lot of not applicable in your responses. And I want to eliminate them from my responses. So that's basically kind of a quick overview of what I do. Once I do my whole assignment, and like I said, I gave you kind of a bridge version, then what I do at the very end is I come back and I do a post-assignment assessment, okay? And I know I'm kind of at the end of my time here, so we're just gonna wrap up quickly. I'm gonna show you my post-assessment, and Kathy, maybe you could put that in Blackboard, in the chat, sorry. And if everyone could just take the post-assignment assessment, and like I said, I gave you a quick version of it, but we'll see how it goes with the post-assignment assessment. This is a similar question. It's parallel to my earlier question, but I've changed it a little bit. So now I have another pie chart, which shows the distribution of individuals in the US with an ambulatory disability or race. And I have a bunch of questions here asking you which of the following is true about this. So I'll give people a minute to answer this question, and then we'll wrap up my presentation. Okay. So I think I'm going to, since in the interest of time, I'm gonna move on. Okay, so even though I only have 9 responses, some people may be shy about trying again. Okay, so here, okay, so what is the correct answer here? Okay, based on the chart above, which of the following is true? I have 9 responses. Of course, we have much smaller samples, so we can't make direct pre and post comparisons. And now I have 10 responses, I guess. Let me just make sure I reload because someone just added. Okay, so yeah, so now I have my 10 responses. Okay, so here, okay, so which of the following is true? Which of the following is true? Okay, so looking at this pie chart here, and we still have 10 responses. It's the correct answer is the red, which is good. We went from about 40% of people getting it correct on the pretest to about 70% of people getting it correct on the post-test. I don't know if the people who didn't respond are selective. There may be some selectivity, but nonetheless, it makes me happy to see a much higher rate of correctness on the post-test. The correct answer is whites are about 75.3 or account for 75.3% of individuals with ambulatory disabilities. These are not correct because they, again, the issue with this, and like I said, I didn't have as much time to go over it, but the issue here is that these are not getting at rates among specific groups. This is getting at the distribution of the population. So among the people with ambulatory disabilities, about 75.3% of them do. Among that population, about 75.3% of them are whites. But if you look back at the chart here, it doesn't tell you anything about how likely these groups are to have ambulatory disabilities, because if you wanted to see how likely Asians are to have ambulatory disabilities, you'd have to put all the Asians together and say, well, we'd have to have a pie chart of just Asians, and we'd say have or have not an ambulatory disability. But that's not what this pie chart is. This is a pie chart of all people who have ambulatory disabilities broken down by race. So these are very difficult concepts, as we can see just from talking about it in this presentation. So I'm really working hard with my students to help them master these skills, but these are very challenging skills to master, and interpreting charts and everything. I think those are important skills, but they're challenging ones. So in wrapping up, I just want to say some going back to the whole concept of assessment, which is where I started. I think it's really important for your assessment to correspond with what your learning goals are. It has to be something that is user friendly, and it gives you useful feedback. Okay, what I get at the end of my assessment is sometimes I find that some students are not getting it, and I'm trying to figure out ways to make it so that my students do get it. I'm always tweaking my assignments, and I think I've made a lot of progress just based on my assessments and seeing how much improvement I see from pre to post, and seeing in what those areas are. And I sometimes have different questions too for different components of my assignments, but I always try and make it really simple, like 2 or 3 quick clicker questions, so that I can get feedback right away and I can use it, and it doesn't take up too much class time or isn't complicated. So finally, I just want to say, when you get your assessment results, that I think that at the very end, if you get useful information, sharing them can be an important thing. And there are a lot of education journals where you can publish about your assessment results. And if you find you have a strategy that's really effective, there are journals. I know there are a lot of sociologists here. There's the journal Teaching Sociology. There's also the journal Numeracy, where they do a lot of work with assessment. So there are a lot of opportunities for you to actually engage in research on assessment. Okay. So that's where I'm ending here. I just want to acknowledge NSF, which has supported a lot of my work. And thank you all for being here today. I know we're wrapping up, and if anyone has any questions or anything, I'm happy to answer them. Or Jill, Kathy, I think you're fielding questions if there are any questions.
I think if you need to stop sharing your screens, I think JP has one more slide to show. Sorry.
Okay.
Thank you, everyone, for sitting through the last 3 hours. But we wanted to provide you with our contact information and a little bit more about one more upcoming webinar. We really appreciate you sitting around, with us through this for the last 3 hours. Talking about numbers and teaching with quantitative data can be, something that's, I think, a challenge for everyone. And by this point, I think Esther or Jill had mentioned, we've been doing these workshops and webinars for a long time. And, we see that not only do students have difficulty with this, but faculty do too. And we see that. And it's something that, we encourage you to spend some time getting to know, what sorts of resources are out there that can really help you make the process of integrating more data analysis into your courses easier for you. With that, I think I'll turn things over to Kathy if she wants to moderate any questions.
I think that there was another question that we just received from Barbara, do you want to just go ahead and ask that question, or I can read it?
Yeah, sure.
Barbara.
Yeah, so I'm a journalist. So, I'm way behind all you guys, which is why I have and also why I have so many questions. That's what I do. But how would I, in teaching this, know to put in that filter about the ages, and instead of just getting all this not applicable responses? What would be the key? I didn't see anything that would indicate that I should do that.
Yeah. So anyways, I think that's one of the things where I said the IPUM's SDA, website is kind of a step up. It does require, I think, a little bit of familiarity. I know about that just because we looked at the ACS, and you can see, and if you don't put in the filter, you're going to see a lot of not applicables. So if you see a lot of not NAs come up, because I could show you, I could run the table, or you can run the table yourself without the filtering, you'll see a lot of NAs. So there was some filter. So if you ever see an NA, I'd suggest you go back to the ACS and look at the question, because the ACS specifically states on their form, only answer this question for people, 5 years or older, or only answer this for 15 years and over. So I'd say if you come up with these NAs, then you want to add a filter.
Okay, thanks. So that getting a lot of NAs would be my clue that I was missing something and had
Getting
to go back.
any NAs will be your clue that there's a filter.
Okay.
There's also another question to Esther. How do we properly explain the row-wise and column-wise distributions to students?
Well, I guess, let me just think.
What's the key difference? There was a follow-up to that.
Yeah, what's the key difference? It's like the same thing, like I gave you the example of poverty, okay? If you were to look at, people in poverty, okay? And you were to, it depends how you set up the table, but one distribution of people in poverty is gonna look at, the base population is going to be all the people in poverty, and then you're going to have it broken down by, of all those people in poverty, how many of them are white, how many of them are Black, how many of them are Asian, etc. But if you structure it a separate way and you have your base population being the total number of people in each group, okay, but actually, then if you have like the total number of Blacks, the total number of whites, and then you express it that way, then you basically have the total number of poverty. You want to think about, what is your base? Is your base the total number of people in poverty, or is your base the group that you're interested in? Is your base like the total number of whites and how many of them are in poverty? Or you want to know it's basically the distribution of those in poverty by race, or rates of poverty by race. And I think you asked me how to explain it. I think the best way, once students do it, I think that's the best way, kind of this hands-on work. Once they do it and go over it and see it, that's the best way to teach this stuff. It's, once you actually go over and you make the tables in both formats, and I make them have to interpret them in the different ways, then they start to understand what are those differences. And I think, I'm also, by the way, I know there's this question, how do we explain it? I'm actually in the process of preparing some videos, because I have another grant right now that I'm working on, teaching data analysis. And this question here you ask, how do we properly explain it? It's getting a concise way to kind of explain this, I think is something that needs to be done. So I'm in the process of preparing a video that does that. And I should have that done within the next month or two. And I'd be happy to send you a link if you write to me.
Do you mind if I quickly answer something about Barbara's question too?
Sure.
Just, follow up with that. And something that Esther was getting at was that some products like SDA, or if you were to actually download and analyze the PUMS data, the microdata directly from the Census Bureau, those require a lot of that extra effort. One of the things that we try to do in WebChip is remove that sort of complexity from it, to really filter for precisely the universe of interest. So you'll notice that a lot of the data sets on WebChip deal with specific populations that might either be year-round, full-time year-round workers, that might be specific racial ethnic groups, or that might be specific age groups. So for example, the elderly. Those have all been filtered specifically for those populations, so you don't have to deal with the filtering yourself. It's really going to be like what Esther said. Anytime you deal with SDA, you might run into some of those situations where you get some sort of NA, and you'll have to track, which of your variables might be causing that. You can kind of identify that when you start looking at the table, but then you have to kind of dig into what is the universe of that variable. And sometimes if you go to the view for that variable, you might be able to see. One other thing with SDA is it works really well with categorical data, but as soon as you work with some sort of discrete variable, something like age or income, you'll start running into very large tables. And so you have to go through some of the recoding yourself. And so there are some guides on their site to recode, but it can quickly get a little bit complicated there too. So.
Well, thank you. That's helpful. So for someone like me who's, a baby with all this stuff and doesn't do it all the time and doesn't want to look like a complete idiot in class, I'm better off using the WebChip, which was the one from University of Michigan that we went over earlier. Okay. Okay. Good to know. Thank you.
So I'm looking at the time, and we want to honor everyone's time. It's been a long day for everyone, I'm sure. So again, thank you for participating, and I want to give a shout out to my co-presenters. Thank you all, and we're all available by email, so feel free to reach out. We all care about this, and we're glad to help out. So thanks again.
Thank you, everyone.